My topic of discussion is equipotent set. What is equipotent set? So, to do an equipotent set, we have to take two sets. Let us define. Let A, B be two non-empty set, and A is said to be equipotent with B if there exists a bijective mapping from A to B. Okay, so an equipotent set from A to B is said to be an equipotent set if there exists a mapping from A to B. There is a bijective mapping, and we denote A is equipotent with this symbol is equipotent symbol. Okay, so if A is equipotent with B, since there exists a bijective, if A is equipotent with B and then B is equipotent with A, since there exists a bijective mapping from A to B and implies that the existence of the inverse of from B to A. What is this? That is F is a mapping from A to B and the inverse mapping F inverse from B to A. If this exists, then this exists. So the two sets A, B are equipotent with each other. Okay, so let us try an example. Let us the relation of equipotence on the set S. On the set S of all non-empty subset of a universal set. What? Universal set. Okay, so what we have to check, that is reflexive or not. Let A belongs to S, and of course A is equipotent with A because the identity mapping, that is I such that from A to A, this is a hold, so this is a bijective mapping. Identity mapping is always factor, so this hold, and so reflexive. Now we have to select two non-empty set A, B belongs to S and A is equipotent with B. Then there exists a bijective mapping F from A to B. Onwards, B is equipotent with A, so there exists F inverse from B to A is also a bijective mapping we have seen before. So तुम लोगों को एक बात कहना चाहता हूँ, यहाँ पे मैंने कुछ भी नहीं किया, सिर्फ मैंने बाइजेक्टिव प्रूव किया. बाइजेक्टिव होने से क्या क्या होना चाहिए? एक रिफ्लेक्सिव एंड सिमेट्रिक. So this is symmetric, and then we have to show that this relation is transitive, and that's all. So A is equipotent with B, that's imply B is equipotent with A. Okay, and the third is let A, B, C belongs to S and A is equipotent with B and B is equipotent with C. So there exists a F from A to B, and also there exists a G from B to C. Now the G compose F is G compose F, so F A B and B C, so G compose F from A to C. This is bijective. A is related to B, B is equipotent with C, that's imply A is equipotent with C. Okay. Two set AB is said to be same potency or the same cardinal number if A and B are equipotent set. Okay, this one kind is to be remembered. Okay, so cardinal number denoted by card of A, this is cardinal of A, card of B, this is cardinal number of B, that's all. Some important thing is said. One, the cardinal number assigned for the null set phi is 0, and the cardinal number assigned the infinite set is transfinite cardinal number. Okay, and the cardinal number of the set of natural number is denoted by small d, and the set of real number is denoted by small c, and so on. Some importance are discussed here. Give you an example which is जो तुम लोगों को खुद करना पड़ेगा, ठीक है. S equals to 1, 1/2, 1/3 and this is equipotent with set of natural number, because the mapping f from natural number to S, that is defined by fn equals to 1 by n such that n belongs to n, is a bijective mapping. So students, for you just check this mapping is bijective or not. Okay, this is bijective, but you can check it out in yourself.